So we're still on module 3 about curvilinear motion, or I mean curvilinear translation. So proceed data for lesson 2, that is about the kinetics of curvilinear translation, wherein we assume that our system is in dynamic equilibrium. So by the end of this lesson, you will be able to apply the principles of kinetics. So balik na sa taan sa mga summation of forces, just like what we did in our previous nga module, katong nagkuan po ta, nagdeal po ta og analysis with regards to the kinetics of a rigid body under dynamic equilibrium, but ang iyahang path, iyang motion is rectilinear. But in this lesson, we're talking about a particle or a rigid body, undergoing a curvilinear translation. So the path is curved. So the kinetics or the kinetic equations of curvilinear translation. So let's say we have here a 2D plane, and then this is a curved path as shown by this gray line, no? Curved line. And then assuming that we have here a particle, kaning solid nga circle, no? Shaded in black. And then we all know that from the previous lesson that we have two components, no, for its acceleration, that is normal and tangent. So with that component, so we need to indicate the axis. So the axis that is parallel to the, I mean perpendicular to the curve at a particular point, is known as the normal axis, labeled n. And then we also have an axis which is which is tangent, no, to the curve at a particular point, and we call that one as the tangential axis or the tangent axis. Okay, and we all know that the acceleration of this particle along the tangential axis is the tangential acceleration, labeled as at. And then the acceleration of this particle with respect, or which is directed towards the center of rotation or the center of curvature, we call that one as the normal acceleration, labeled as an. Now, if we assume that this particle is subjected with external forces, so we need to resolve, no, all those forces, or we need to sum up those forces that is along these two axes, the normal and tangential. So let's start with the normal axis. So we sum up all those forces, no, kung unsa man ang mga forces nga niigo ani nga particle, and then the summation of all those forces, we call that the resultant normal force, labeled as Rn. Okay, and of course nganong naa siya padong ubos, because we assume that the downward force is positive, because the direction of our acceleration on this axis is pa downward, which is our normal acceleration. Now, to make this particle in dynamic equilibrium, so we need an equilibriant force or a reaction force, which is opposite in direction but equal in magnitude, and we call that one as the reverse effective. So what we have here are EFN. This means that there is an equal force but opposite in direction. So we call this as the reverse effective normal force. With this, our particle is now in dynamic equilibrium with respect to the normal axis. So we call this resultant force Rn, no, resultant normal force, as the centripetal force. So when we say centripetal, kay maglibog man tanang duha, no, we have centripetal and we also have centrifugal. So when we say centripetal force, that is center seeking force. So ang iya direction is towards the center of the curvature or towards the center of rotation. Whereas the centrifugal force is the um kanang kuan reverse effective force mo na siya yung counteract sa centripetal force, and both forces are equal in magnitude, no? So kana equal niya siya si REFN and si RN. Okay, so ayaw kalibog na. Now, after we analyze the summation of forces along the normal axis, let's proceed to the tangential axis. So sa tangential axis, the same thing that we did sa normal, but before that ato day pakita ang iyahang mathematical expression for the normal. So meaning summation of forces along the normal is just equal to the reverse. So this is the reverse effective normal force, which is equal to the mass of the particle times its acceleration. But the acceleration along this axis, along the normal axis, is labeled as AN. And from the previous lesson, the formula for the normal acceleration is v squared over r. Okay, now proceed ta sa tangential axis. So along the tangential axis, again the same thing sa normal axis, we sum up all those forces na nag-interact sa ato particle, and then we have the resultant tangential force which is acting upwards, no, along the direction of the tangential acceleration. So 80 padong na siya. And of course, to make this one in dynamic equilibrium, so we need to have an equilibrant force, no, or na ay mo counteract niya, which is same magnitude but opposite in direction. And we also call that one as the reverse effective tangential force, REFT. So in mathematical terms, that is the summation of all forces along the tangential axis is equal to the mass, or that is the weight divided by the gravity, times the tangential acceleration. So this time, tangential acceleration na. And added information, the tangential acceleration is also the product of the radius of curvature, because this particle, no, since niyagi siya sa curve path, at a particular position, it has this radius of curvature. Okay, so the radius of curvature times alpha. What is alpha? So alpha is our angular acceleration. So na mga problem nga given na siya, ug ang iyahang unit kay naka-radian dapat radian per time, depende kung second ba or minute or hour. So radian per time square. Say for example, radian per square second. So that is our angular acceleration labeled as alpha. So don't forget this one. Kanay ubang problems, hatagan mo og alpha. Okay? So sa ato previous nga lesson, ang inyo na naibawan is the tangential acceleration is equal to the instantaneous acceleration, which is dv over dt. Kaning duha nga expression, same lang sila og interpretation. This one is in terms of the angular acceleration. Okay? So, nganong mag-analyze man tayo ni unsa may mga applications na yan. First is ang simple pendulum. So, familiar ba mo ani? Kanang kung ating may tabyog-tabyog, so mag-remain na siya tabyog-tabyog, pero since na may friction, so muundang siya. Okay? So, mani ang pinakasikat na yung example. So, sa ato ang simple pendulum, of course, na siya central axis, kani siyang vertical line, and then of course it has a pivot point, and then nakasuspend ang ato ang object, no, kani siya gray, and then gitali siya or gi-connect og sa rod or a string, no, depende, which has a considerable length L, and then of course this object is inclined with respect to the vertical axis by an angle of theta. Okay, for a simple pendulum, the movement of our object, no, is paana siya, so pa circular, no, paana siya, mo reach siya sa bottom, tapos mga to na pod sa pika side. Okay, reaches is its maximum height, so this is iyang maximum height nga ma-reach, no, with respect to the ground or to its lowest position, so h max. if ever walay air resistance, no friction, no, especially sa air o sa kaning iyahang pivot point, if walay friction, so it will continue to oscillate, no. So this simple pendulum continue to oscillate. However, if na mga friction, then mo stop na siya. Okay, so ang atong object, of course, it has a weight W, and then of course our rod or our string has a tension, no, at a tensile force. So unsa may pag-analyze nato diri so mupilit ano ato to i-define to ang mga given ng mga axis. So let's start with the tangential axis. So since mo ni ang iyahang path, no, kani, so ang ato ang tangential axis is tangent ni ana, no, paana siya. So this is our t, and then our normal axis is perpendicular to the curved path at this point. So paana na po ang ato ang normal axis. Okay, and then if this is theta, no, by geometry, the angle between the normal axis and the weight is also theta. Okay, so therefore the weight can be resolved by two components along the normal axis. So this is W, this is cosine of theta, and then along the tangential axis, this is W sine of theta. Okay, and then kani siya kay ang iyang movement is pa downward man, so it is expected that our acceleration is pa downward. So this is the direction of our tangential acceleration. So always note that the tangential acceleration is along the tangential axis, and then of course pasulod gid na ang ato ang normal acceleration. So this is our normal acceleration. However, no, ang iyahang reverse effective force kailangan nato i-define. So diri since si tangential acceleration is paubos, it is expected nga yung equilibrium force is pataas diri. So this is our R E F T, the reverse effective tangential force. The same pud sa to ang normal force, no? Normal force padung man ngadto. So expected nga ang ato ang reverse effective normal force is pa down pud. So paana pud diri This is our R E F N. So ato first nga analysis is at the normal axis. The normal axis. Okay, so we take summation of forces. No, we take summation of forces along the along the normal axis. That should be equal to 0. So nganong na 0 naman, it's because dynamic equilibrium na. If wala pa gay nato gisuwat ning REFN, no, if wala na to isuwat, then dili ni siya ma-0. Okay, so remember that the value of our REFN is equal to our resultant normal force, which is equal to the weight over gravity times the normal acceleration. So since ato nang gisuwat dito diri so the summation of forces is not equal to the mass and acceleration but equal to 0 na. Okay, kay ato naman gikuha ang resultant force diri Okay, so with this one pag sum up nato sa mga forces, so ato i-take nga kanang positive siya. So positive siya if pa-upward. Okay, positive siya if pa-upward. So unsa man nga direction natong gi-follow, this is also the direction of our normal acceleration an. So therefore, unsa may mga forces nga may act upward, so we have the the tension of this rod or string. So we have the T. What else? So we have the normal component of the weight. So that is minus, kay paubos man siya. So minus weight cosine of theta. And what else? So the reverse effective normal force. So minus the reverse effective normal force, REF, and that is equal to 0. So substituting the value for REFN, so we have tension minus weight cosine of theta minus W over G times the normal acceleration is equal to 0. So we can use this expression to solve for one of its parameter, either unknown diri si tension, or unknown baka diri ang theta, or unknown baka diri ang normal force. Okay? Don't forget that the normal force is equal to the square of the velocity over the radius. And what would be the radius for our simple pendulum? So the radius is equal to the length of the string or the rod. Okay? Mao na siya. Mao man ang radius kay pa-circular man siya, okay? Paana man ang pagtuyok sa atong object. Okay. So mag-perform pud ta, no? Og summation of forces at the tangential axis. Okay? Tangential axis. Okay? So we have summation forces along the tangential axis is equal to 0. So we take positive if pa downwards siya because that is the direction of our tangential acceleration. So we have the reverse effective tangential force is equal to the resultant tangential force, which is equal to the weight times G times the tangential acceleration. So the same thing, unsa may forces nga nag-interact along the tangential axis, we only have the component of the weight. Okay? So sila ra duha. So si component of the weight is that is 0. Okay? So that is 0 man siya. And then siya man mo ay siya may paubos, so siya ang positive, no? So we have W sine of theta, tapos si reverse effective tangential force dayon, so minus reverse effective tangential force is equal to 0. So weight times the sine of theta minus W over G, tapos we have the tangential acceleration that is equal to 0. So you can use these two equations, no, to analyze the kinetics of an object under a simple pendulum. So ang next niyang example natay gitawag pod nga conical pendulum. So sa conical pendulum, mo niya illustration, same thing, nagkabutay vertical axis, natay pivot point, kani, and then gina-suspend gihapon ang atong object. Okay? And then it has a considerable length L. And then of course, we have an angle of theta. But this time, instead of oscillating this one back and forth, so ang iyaha is, of course, na siya height. Forget this height. Ang iyaha is, ni kuan siya, no? Ni perform siya og circular motion along a plane which is perpendicular to the vertical axis. So this horizontal plane, kaning circular plane, na siya radius nga r, and then of course kani siyang object rotate siya at a certain velocity in this direction as shown in this figure. And of course nagyapon siya weight, then nagyapon siya tension, and then nana siya gitawag nga centrifugal force. So remember ha, in this circular motion naatay normal force padong niya, no? We have Fn here. And also diri we have tangential. So, di ba? The equilibrium force of our resultant normal force is equal to the Re Fn, no? This is the Re Fn, which is equal, or in other words, or another term, that is the Fc, or the centrifugal force, no? Centripetal maning padung sa center. Okay? So, mo nang naadri ay Fc. Remember that this one is the normal axis and nara ang tangential axis. Okay? So, the normal axis, kana siya, nara ang tangential axis. Okay? So, by having this three main nga mga forces, our object is now in dynamic equilibrium. So, tuluman, i-review nato ang katong ato ang knowledge sa statics nato. So, if three forces, we can create a triangular polygon, no? So, we have the weight, then we have the detention, no, paana, and then we have the centrifugal force. So, this is the weight, the tension, and the centrifugal force, which is equal to the REFN, or the weight over G times the normal acceleration. And this is our angle theta. So this is the building block of a conical pendulum. So by this polygon, by this force polygon, we can derive a relation that exists between the weight and the normal acceleration. So if we take the tangent, no, tangent of theta, okay, we have the ratio of the weight over G times the normal force. So makancel si weight, mabilin sa bawo is G over the normal acceleration. However, our normal acceleration is equal to the square of the velocity, no? The square of the velocity, and then, I think nabali na to og express ang tangent. Kani siya, sorry. Tangent is opposite man day. Sorry. Kani opposite, so ang opposite sa angle is ang centrifugal force, which is equal to W over G, normal force over the weight. So makancel si weight, we only have normal force over gravity. The normal force is V squared over R G, so therefore we have a relationship of tangent theta equals V squared over GR. So meaning independent, no, independent ang ato ang theta function sa weight sa ato ang object. So whatever the weight, we can still arrive kanang same magnitude of our angle theta given the velocity and the radius. Okay, so from here we can also solve for kanang theta in terms of the length pod, no? So remember, okay, so ayon ni kalimtin, no, i-take note ni siya nga formula gamit kani tan theta equals V squared over GR. So we have our first formula. Now the second formula is number 1. Number 2, so ato ikuan nga let, no, let R is equals to, now if we extract this triangle, so nata dry length, this is the height, and this is our R. Okay, this is theta. So our R equals length, no, length sine of theta. Okay, so if we substitute that one, so natay tangent theta equals V squared over G times L sine of theta. Now, at a cross multiply, we have V squared equals GL. The tangent of theta can be written as sine theta over cosine of theta. Tapos, we have sine theta. So, therefore, sine squared na siya. So, combining V squared, or we can multiply both sides by cosine theta, over GL. So mahimo ni siya og b squared over GL cosine theta is equal to, this is sine squared theta. But sine squared theta is also equal to 1 minus cosine squared theta. So rearranging, we have cosine squared theta plus v squared over GL cosine theta minus 1, that is equal to 0. So if you let cosine theta as x, then this equation would reduce to a quadratic function. So you can now solve for x, and consequently you can also solve for theta. So this is another formula sa conical kanang pendulum. So na tayo first formula, second, and let's derive the third part. So number 3, again ato i-draw yung balik. So we have the tension, we have the weight, we have the centrifugal force, which is equal to Wg times the normal force, the normal acceleration. So magkanta og relation, no? Relation between the tension and the weight. So from this triangle, we can say that the weight is equal to the tension cosine of theta, or in other words, we have tension equals W over cosine theta. So kanila, no? Don't forget this one for a conical pendulum. The last one, we are going to find the total time nga ma-complete niya ang usa ka tuyok, no? That is also very important because it talks about the period, no? Sa conical pendulum, sikat ang period o ang frequency. Pasabot sa frequency, unsa siya ka ano, kana magbalik-balik siya og tuyok from its initial position, mo travel siya niya, mobalik na po sa initial kanang position. So we're going to solve for the period. The period talks about the time and then frequency, or how often nga magbalik-balik siya pagtuyok aning usa ka circular path. Okay? So remember that the velocity, no, the velocity v is equal to the displacement over time. So ang total displacement, no, kung mutuyok siya nga circle, is equal to the what? The circumference. So the velocity is equal to the circumference of this circle divided by the time. We know that the circumference is 2 pi r all over time. Now, to solve for time, so since we're talking about the period, so time is just equal to 2 pi r over the velocity. Now we are going to look for an expression of the velocity. Now we all know that from the previous slide, no, the velocity, pwede ta makadrive diri, ano, ang velocity is equal to the square root of gr tapos tangent of theta. Okay? Muna siya to ang velocity. So we're going to use this one. So the velocity, again, 2 pi r square root of, this is gr tangent of theta. Now, para ma-modify nato, no, kung ato ni ikuan, kung ato ni i-modify si r, actually ang r, no, kaning nasa numerator, the r can be written as the square root of r square. Don't worry, both are the same, no? Kay matangtang square root pareha gyapon. So let's do that. So we have time equals 2 pi. Sa babaw na square root, so we have r square sa babaw, sa ubos, gr tangent of theta. So makancel lang sa ka-r, so mahimo na siya og 2 pi square root of r over G tangent of theta. Okay? So anong gibuhat man to? It's because we have a relation no sa r o sa tangent of theta. So if ato to ibalik tong triangle diri we have the height, the length, theta, and this is the r. So the tangent of theta is equal to r over h. So therefore, h is r over tangent of theta. So kani h din ni siya. Okay? So that is equal to 2 pi square root of h over g. Okay? So as theta approaches 0, no? Kung ang kani ba? Kani magkaanam ni kaduol aning vertical axis if this rod or if this string no magtikanag kaduol sa vertical axis, then ang ato ang height no ang ato ang height mo approach siya sa value sa length sa ato ang rod no length sa atong rod or string magkapareha na sila, so therefore we can substitute h by l. So the period or the time t is equal to 2 pi square root of l over g. And then for the frequency no ato siya labeled as f lang. Actually ang frequency is just the inverse of the period, so that is 1 over t. Okay, or the time t kana time t, that is equal to we have 1 over 2 pi square root of g over l. So nabali lang, and ang iyahang kuan is kuan ni siya kanang naka regions pa ni siya no, so rad pa ni siya, rad per second, and then dria is per second, I mean second, because time na siya. So natay additional nga formula that this one is the period and this one is for the frequency. Okay, wala siya ilabot sa multiplier ha, ato lang tangtangon na lang para di maglibog kaysa dimension na niya. Okay, so naipangutana so far. Tingnan nabay nag-chat or nag-raise of hand. Okay, sige. Nawala ang height. G tan theta. Wala na siya nawala. Ang equivalent sa r over tan theta is equal to h. Kani siya nga triangle sa left side. Kani. So mo nang nahimo na siyang h over g. Okay. Ang uban. Walay pangutana ni. So again, pasabot ang period. How much time no would it take for this object to travel this circular path from its initial position, mutuyok siya, then going back to its initial position. Muna pasabutan ng period. The time to complete one revolution. Okay. So frequency ang how often pud nga magbalik-balik siya ana ang pagtuyok sa usa ka revolution. So that is the inverse of time. So okay, for na pangutana, then let's proceed to some problems. So first problem, a rod 4 feet long rotates in a horizontal plane about a vertical axis through its center. So ako lang pakita daan ang illustration no. So ang rod nga gipasabot ani is kaning horizontal, kaning gray no. Dark gray nga mura siya og black. So 4 feet iya hakatas-on. So ang halfway ana niya is 2 feet. Unya nituyok na siya, rotates horizontally. So, paana yung rotation? Paana. Then, ni-rotate siya about a vertical axis through its center. So, the geometric center of a rod is kanaya ito nga. Ito siya. Yeah, at each end daw of the rod is fastened a cord 3 feet long. So, kada tumoy-tumoy niya na ay cord 3 feet long. Tapos, naga-support siya og weight W. So, left o right, naa siya i-support nga weight nga W. Then, the requirement here is to compute the speed of rotation in RPM. So, N ang indicator. So, the required is N, speed of rotation. Speed of rotation, that is in revolutions per minute. Manay pasabot lang RPM, revolutions per minute. So, to incline daw each chord at 30 degrees with the vertical. So, this 30 degrees, muna siya pasabot ka ni. Okay? So, may buong mo, asa ka ani ang radius of rotation, sir. So, basig ang uban kanila inyong tanawon nga triangle, no? Basig inyong radius kay kani. Kay kana. Kay tungod naanan mo atong figure. So, wrong na mo daan. Remember nga ang radius is drawn or is measured from the object towards the vertical axis of rotation. So, gikan ta ng object, padong gid nga ri. So, this is our R. Kay dira man mo tuyo ka ato ang object. Okay? So, our R is equal, no? Solution. Our R is equal to this length plus this additional length. Okay. So, for the solution, to solve for the RPM, we're going to use the first equation, no? Katong tangent theta is equal to v squared over gr. So why I am using this one? Because the tangential velocity of our object can be expressed as, no? This one can be expressed as the radius times the angular speed Rn. O mo na ito ang gipangita. Okay, so therefore we can write that one as Rn squared over gr. So mahimo ng r squared, n squared all over gr. Cancel ang r. So we only have n squared over, I think, Rn. Okay, Rn squared over g. So solving for n, so n is equal to r over g tangent of theta. Square root na siya. Okay. So wala tay r. So to solve for r, no? Solving for r, so from the illustration, r is equal to 2 feet, kani siya 2 feet, plus this one, x. Let's say this is x. Okay. So from the figure, no? Dili na to i-extract. So ang length sa cable kay sa cord is 3 feet. This is theta, which is 30 degrees. This is x. So we can use sine identity. So sine of theta is equal to opposite over the hypotenuse. So therefore our x is equals to 3 sine of theta, which is equal to 30 degrees. So 2 plus x. So therefore we have 2 plus 3 sine of 30 degrees. So we can use our calculator. 2 plus 3 sine of 30. So the result is 3.5. So 3.5 feet. With this, we can solve for n. So therefore, n is equal to the square root of r, which is 3.5 g tan theta. So we have the radius 3.5 feet divided by 32.2 feet per second square. Tapos tangent of 30 degrees. So makancel ang feet. Expected answer ani is per kuan siya, per second, no? So ato i-solve. We have square root. So our radius is 3.5 divided by g, 32.2 times tangent of 30. Okay, so ang result is 0.43389. So 0.43389, but this is still in radian per second. So rad per second. So let's convert this one into RPM. So next we have n equals 0.43389. This is a rad per second. So to convert that one into revolution, so ang usa ka circle 2 pi rad na, no? So 2 pi rad, that is 1 revolution. Ang second 2 minutes, so that is 60 second is equivalent to 1 minute. So cancel radian, cancel ang second. So the final answer is in a revolution per minute. So i-store lang nato ni siya. So answer times 60 divided by 2 pi, shift pi. So the answer is 4.14. 4.14. Okay? And I think murag na isayo na. Okay, diri ang part, sorry. Kanina nabali ni batog ra nabali. Ang kani siya, this one, kay ang tangent of theta bantog ra gamay. Ang kani siya, if ato ni siya i-cross multiply, our n is equal to g tangent of theta all over r. So nabali ra din siya. Nabali ra ni. Okay, so this is g tangent theta over r. So this is 32.2 feet per second square. Tapos tangent of 30 degrees divide by 3.5 feet. No, para ma per second squared siya. Sa talabalikon, we have square root 32.2 tangent of 30, then 3.5. So 2.3047. 2.3047. So diri this is 2.3047. Therefore malhi ni siya to ang final answer. So i-store na to answer times 60 over 2 pi. Okay, so ang atong answer is 22.0008 or 22 na lang. So 22 RPM. Okay, so this is our final answer. So naipangutana na? Naipangutan na class? Wala ra? Okay. So, proceed ta sa number 2. Kani siya, application ni siya sa conical pendulum, no? But for number 2, mili ko problem nga application sa simple pendulum. So number 2, the hammer of an impact testing machine weighs 64.4 pounds. It is attached to the end of a light rod 4 feet long which is pivoted to a horizontal axis at A. So muna siya iya illustration. A is the pivot point. Kaning gray nga circle muna siya nga to ang representation for the hammer. And then the question is, what is the bearing reaction just before impact at B if the velocity of the hammer is then 5.9 feet per second? So ang ato analysis ani naa na siya diri sa point P. And then iyahang velocity diri so again, the absolute velocity of a particle undergoing curvilinear motion is always tangent to the path. Ayaw ginakalimti. So 5.9 feet per second na siya sa point B. Aning ato ang problem pagpangutana. So ang pasabot aning bearing reaction, that is the force experienced by our kani pivot point, no? So ang atong required ani is the tension. So requirement, the tension. That is in pounds. So solution. So since this is simple pendulum, so ato i-drawing ang iyahang position at point B. So at point B may ani na siya, no? Point B mo ni ang pivot point. This is A, this is B. So ang force nga interact, we have the weight, and of course nag-move na siya, no? Mo na siya ang iyahang velocity. So ato i-kuha ang iyahang normal and tangential axis. So ang normal axis mo ni siya kani. So ato lay ana pwede magdibog sa kani. Mo ni ang normal axis. Mo po ni ang tangential axis. Okay. So sa normal axis, of course, since this is our pivot point or the center of rotation, kaya mo rotate mo siya paana. So the normal axis is act towards the pivot point A. Okay, paana. So therefore, expected nga ang iyahang reverse effective normal force is opposite. So pangadto, we have R, E, F, N, which is equal to the Rn, or which is equal to the weight over G times the normal acceleration. Okay, ang ipangitaman kay si tension naman, so si tension pataas. So therefore, mas dali kung mag-take ta og summation of forces along the normal force. Since na naman ato naman gi-indicate ang reverse effective normal force, then the state of our particle here is now in dynamic equilibrium. So we now take the summation of forces along the normal kanang axis and equate that one to 0. Okay, so summation of forces along the normal axis is equal to 0, wherein we take positive if ang force pa upward. So why I choose the upward? Because that is the direction of our normal acceleration. So ang sa may mga upward forces, so we have the tension. Now ang weight paubos naman, so minus the weight, and also the reverse effective normal force, so minus the reverse effective normal force, wala may lain, so 0. So since si tension gipangita, so tension is equals to the weight plus the reverse effective force is equal to the weight over G times the normal acceleration. So ang atong normal acceleration can be expressed as the square of the velocity at that particular position all over the radius. But the radius for our simple pendulum is just equal to the length, no, of this rod or string. So ato i substitute na W plus W over G times the square of its velocity all over the length. Okay, so plug and play lang. The weight is 64.4 pounds plus 64.4 pounds divided by 32.2 feet per second square. So our velocity is 5.9 feet per second divide by, okay, sorry, square pa na siya. Divide by the length. The length is 4 feet. So 4 feet. Okay, so unit analysis. Ang feet, no, square na sa babaw. So feet square na diri all over second square. So na may feet sa ubos, makancel, feet na lang. However, napoy feet diri so mawa na gyud. And then ay second per second square sa babaw, napoy per second square sa ubos, so makancel. So therefore pounds gyud diri then pounds. So makombine sila. So therefore ang expected nga dimension for our final answer is in pounds. So 64.4 plus 64.4 divided by the acceleration due to gravity 32.2 times 5.9 square divided by the length of 4 feet. So the answer is 81.8. Okay, so 81.8 pounds. So this is the magnitude of the bearing force that is experienced by the pivot point A. Okay, as this object oscillates from, or as this object approaches to this point B. Okay, so naipangutana ani, naipangutana class. Kaya ako lang i-end ang